Hello, everyone. Thank you for joining us for this very first webinar for our center. It's called Carnations. That's center related to transit resiliency of transportation systems funded by Department of Transportation. My name is Moussa AYYASH. I am a professor from Chicago State University. And with me is also Dr. Black. She's a co-director for our Center of Information Security Education and Research. We call it CINSER. And this is our first webinar for the 2024, fall 2024. And it's my pleasure to welcome Dr. JIAN TAO from Texas A&M University, who accepted to be our first webinar speaker for this series. And he will be talking about an important topic related to transportation systems in general. He will be talking about the Carla simulator. Professor Tao, he's a professor, is assistant professor from the section of visual computing and computational media in the School of Performance, Visualization, and Fine Arts at Texas A&M University. And he is also the director of Digital Twin Lab and assistant director for project development at the Texas A&M Institute of Data Science. And we are very glad he's available to give us a talk. And we have 1 hour for this. He will be doing his presentation, and then we can entertain any questions for attendees. Please feel free to write your questions in the chat area. The school did not activate the audio video, so the audio feature. That's why we'll be entertaining your questions via chat and pass them to the speaker as needed. Dr. Tao, you have the floor is yours.
Thank you so much, and thank you for the invitation. And let me redo the slides here. Hopefully it's better and better. Yeah. So again, even though my college is so-called as Performance Visualization and Fine Arts, my background is in physics. I have been doing computational astrophysics for many years, and doing a lot of physics-based modeling, numerical simulations, data science, AI, machine learning. That's actually my focus here. And this project started as a undergraduate student project, which is quite amazing. And that's the first time I got to really start working with students here, especially engineering students, to get started on this project. That's how, for some reason, I think this probably is the way how I get myself into digital twin domain, mainly because of this project. And so today I'm going to talk about this project on the exploring the auditory perception for autonomous piloting with Carla simulator. But I want to just go through a little bit more about the background of this project and how it was started and how students got involved. And this could be probably one of the examples that some of you might be interested to look into, to incorporate this kind of research into educational programs as well. So let me start by introducing the Digital Twin Lab that I led this effort to establish in October 2022. That's about 2 years ago. And it's one of the first lab that is focusing on developing digital twin technologies at Texas A&M. So it's one of the thematic labs at Texas A&M Institute of Data Science. And the goal of the lab is trying to provide a hub for collaborative research on digital twins, which is getting really popular lately after the publication of the National Academy of Science and the Engineering paper, or the report. And we have about 12 members and 9 different organizations. And we have multiple supported projects and pilot projects ongoing. And we also work hard to collaborate with faculty members in different units to get the program going. So at this point, I'm working on a digital twin certificate that which is a collaborative effort among multiple colleges. So this is a project I got started a couple of years ago. before I joined the School of Performance Visualization and Fine Arts and the tenure track faculty member, I was a research scientist at engineering, College of Engineering at A&M, and I was asked to propose a project to work with all learner students here in the College of Engineering. And I proposed this project. Back then, the only thing I know about autonomous vehicle is just the very basic information you can find online. And in the last several years, I got into multiple projects and proposals relevant to autonomous vehicles through this project. So you can find more information about Anki Chen and other things. I can post a link later on and on the website. It's a very cool project program at A&M to help engineering students get started with all the latest development on different fields. And also myself was involved in this auto drive challenge team, and A&M is one of the, I'm not sure, probably 10, 12 teams participating in this auto drive challenge organized by SAE, Society of Automobile Engineers, and also General Motors. So this is already the second time. So for every, it started with I believe it started in 2019 or 20, I forgot the exact time. Dr. Daisy Jen was leading the team, won the first place in the overall dynamic event. And then last summer, it's the second round of this competition, and got won the champion of the second autonomous auto drive challenge competition. And some of our team members working on this color-related projects was involved in that one. Even though color was not used officially in the competition, but we did use color to start building this networks for following the Open Drive standard and help lay out the framework that for some of the works that adopted later on by some of the students. Two of my students they were involved in this competition. They were presenting over there for this work. The team leaders for this project was primarily by one of the students from computer science. As you can see, they were both undergrad students. Nina currently is working at Goldman Sachs at Dallas as I believe a software consultant, and also Alisa Cassidy is currently working with me as a graduate student in our school, and he has been doing a lot of wonderful digital twin design work for us. And also this project actually involves a contribution of, I believe, probably more than 50 students in the last in those 2 years. As you can see here, this started like 4 years ago in 2020, and lasted for about 2 or 3 years. Just for the project, and later on my team picked it up and continued doing some development work. So the vision of this project, when we got started, we were trying to build a digital twin for the Texas A&M system, Raleigh campus, and it's a brand new campus designed to host latest engineering, large-scale engineering projects. There are multiple ongoing constructions over there. Just to build the facilities for large-scale engineering and science projects. One of them is a detonation tube that I probably mentioned before to MOUSSA, but you can find some information there. There are a lot of activities for military training and also experiments on the Raleigh campus as well. So for this project, we are trying to build this open platform that we want to make it available to our researcher teams, especially for the auto drive challenge team back then, for them to use this for testing their software and algorithms before they start deploying their code or algorithms on the real vehicle for testing and demonstration purpose. So another reason why I think this will be very good for education purposes, that it's a really multidisciplinary effort. And in the college engineering at A&M, there is one department called the multidisciplinary engineering department, and students are able to design their own PhD programs. And and we are offering similar programs for our students as well, for other students as well. So for most of the students who participated in this project, they were enrolled in this program, trying to learn not only from the engineering faculty members about how they build their models to drive cars. They also learn how to build these maps and with some architectural and design perspective in this kind of work. And lastly, there is a 5G testbed. Now I think there are multiple 6G testbed ongoing in the discussion. But back then, when this project was started, and a 5G testbed was a state of art, and we were trying to figure out a way to integrate with the 5G testbed, but it's still the ongoing process at the moment. So essentially, the project including 3 stages. First one, we try to build a map. Again, this is like a semester-long work for the students, from knowing nothing about MathWorks, Roadrunner, to start building this, nice and standard conforming map in about a semester. So the second semester, it's every semester we got a group of students joining this effort. Some of the students are repeating as repeating members. So for the second semester, we start building 3D environment, adding 3D assets in the Unreal Engine or Carla directly using the Roadrunner. The third semester, that's the last semester I was in charge of this project, we started working on the autopilot system, utilizing the water maps and 3D environment we already have. So again, all these are done in a very systematic manner, in a sense that we want our students to learn the whole pipeline, even though they spend a lot of time building the 3D map. So they did use existing town hall maps in the Carla to do some experiments to learn autopilot systems. But as far as the project itself is concerned, we divide the task essentially into these 3 stages so that we can have focused effort among the whole team. So for the virtual map, this is what we did. This is about the course. So it's a 3-credit course, it's a special topic course in engineering. It's got 3 semesters from 4 to 2021. So for the map, as you can see, the map here is pretty big. So what we did is just a divide and conquer kind of method. We take the high fidelity map of the Relics campus and cut them into pieces manually. And we ask each team, so we have we divided the first group of students into multiple teams. Each one just takes a small piece and constructs that map. And then towards the end of the semester, we put them together. And we got not only the visual component for that, more or less like the roads and other things. There's traffic lights as well. We also have the so-called open drive networks, which are essential for autopiloting on the system level. Basically, you don't need any tools to drive your car. Your car will be following this open drive networks, and there are given standard about red lights, green lights, stop sign, etc. So the car knows the signs, and Carla can handle the autopiloting on the system level, which is essential for simulators like Carla, because you don't need to have someone behind it to train the model to make the car running around. So you can have a car run just like a toy running on, in some tracks, in a mall or somewhere. So we have seen those. So the car can run in this environment. You can keep dumping data for this environment. And the data could be used to train your autopilot program. And then you can go back to drive your car from the client side. So there's a server-side autopiloting and a client-side autopiloting. So the server-side autopiloting is controlled, and the open drive network will provide the guide rails for the server-side autopiloting for dumping data and generating the input for training the model. And as on the client side, it's completely up to the user. You can develop, algorithm-based or rule-based model to drive your car, or you can develop neural networks to drive your car. So for our students, we're mostly focused on the second one, because after you build the model is ready, and the open drive network is ready, we can get the autopiloting data dumped for us, for the users. That's why I think it's important for students to get started from the scratch by building all these maps, and then we can move forward to the next stage. Then adding buildings to this Carla environment is it's a non-trivial task if I'm new to this. But fortunately, there are a couple of tools you can leverage. One of them is a RoadRunner from MathWorks. MathWorks acquired RoadRunner while we were taking the course. I believe that it was called a Vector. I forgot the name of this of the company. And MathWorks acquired a company and make RoadRunner one of the modules that if you get the full license of MathWorks, MATLAB, you can get a RoadRunner as well. So it's coming with a MATLAB. Sometimes, depending on the license your school may have, it might not be coming for free. You need to pay some extra fees to it. So it's a commercial software here. So RoadRunner. And so RoadRunner has its built-in editor. So you can add this 3D asset already predefined, like buildings, etc. You can easily change the look of the building and all the other objects directly from the RoadRunner environment. But another way to do it is you can use Unreal Engine directly. Unreal is free unless you are making a lot of money. For example, you are getting like 1 million income, then you probably need to pay some fees to use Unreal. But for most of the academic research, Unreal is completely free to use, and it's also open source. And you can download it. You can use Unreal to edit the 3D environment and then dump it to Carla. Carla can import the 3D assets, and then you have the 3D environment ready for you. So in our course, we have students from our school who are more familiar with Unreal. They can directly edit the 3D assets using the Unreal Engine. We also have students from engineering that are not so familiar with Unreal Engine, so they use RoadRunner. So that's how the collaboration got started. So then after the 3D assets are ready, you can start inserting all the like trees, buildings, stop signs, traffic signs, and whatever in your environment. So these are all static environments. Those are not actors. Actors are talking about, cars, bicycles, motorcycles, etc. But here we're talking about static environments. So these are the ones that will be staying there. You can create some animation for trees, maybe. I don't know what's the latest, feature that Carla is providing, but you can provide some animation. So you can see the trees moving. You can also link this to some dynamic weather system. You can have the sun's position actually reflecting exactly the position of the sun at your place, depending on where you are. There are such plugins in Unreal you can leverage and make this environment really realistic. So after you get these 3D assets created, you can start dump that into the environment and then import it in Carla, and that's it. But again, the details are in the devil. I'm sorry, the devil's in the details, and a lot of things could be going wrong. And for example, one of the problems we had when we try to merge all the maps from all the students, the roads are not lined up. So we have to get someone like Lisa or Nina to help us to make sure all the lines are lined up, and then they can merge them. It turns out actually they did a lot of work just to merge all these graphs. But again, that's the process. It's kind of divide and conquer, kind of way of doing this map creation, and you have to get all students to motivated to learn something. But you still need someone just to help them to get everything put together. So after you get the map imported, the next thing, exported to Carla, next thing just loaded, just like loading a regular town hall map or town map that you have been, using probably if you're using Carla. There are multiple town maps, and I'll show one of them towards the end of this presentation. You can directly use them. They already have all very nice virtual cities created and the rural areas created. There are multiple maps there. And you can load your environment and put your car in it. It will follow the open drive network without you doing anything. So that's how you get all the server level autopiloting system started. Now the next thing is start doing the autopiloting. Now it's mostly doing this through the client side. So Carla provides a Python API for you to write your Python code to control the whole environment, as well as doing the autopiloting for people working there, for cars, for motorcycles, even for anything. There were even Cybertrucks models in there, so you can pick a Cybertruck and get it running in the environment. So on the server side, it's providing the rendering of the map, giving you the very nice game-like environment. So you can change your views, just like when you're playing racing games, right? You can switch different angles of the camera, perspective of the camera, and then you can see it from your first-person perspective, third-person perspective, and different sides, etc. So that's very, very flexible. It's very, very useful with this kind of feature to dump the data from different perspectives. When some of the accidents, if you heard about it, some accident happened because the the real life accident happened because people, when they're trying to use the autopilot system, the model trained to recognize the back of a car might not be recognized some other side of the car. For example, when a truck is tilted over, the top of the truck, it's just not in the regular training data set that a car model, autopilot model is used to be trained upon. And I believe one of the accidents happened. You can check the news. I forgot exactly when. That's probably either Tesla or some other car. I forgot. So don't put me on be responsible for the comment. But the reason why the car crashed is that the model just couldn't recognize what's in front of it, and because it doesn't see it. I've never seen such a view, and you have to have the data there to train the model. Without the data, the model itself is just knowing nothing about the environment. It has to provide the information to it. So Carla is able to put a camera at every angle, 360 angle. You can put any position and with different perspective. Depending on the requirements of your model, you can capture all the corner cases, which is quite unusual. That for you to, when you collect data for training your models, you may be able to get those kind of cases. They don't want to crash your car just to get the data to crash your car. Sometimes we do some damaging experiments just to capture those data. But in this autopilot system, in Carla, the data will be coming for free for all these corner cases. You can create a crash the car scenario and anything you want. And this will be providing a lot of data for Carla to be more to be used for those training those autopilot models. And on the client side, the APIs is in Python and make it very easy to connect that to all the other machine learning models and also deep neural network models directly. If you have a PyTorch model, either doing large language models or could be anything, it can easily integrate it. So information could be go in and out through this Carla API, which make it really, really powerful to link to many other projects, depending on what you want to do. And it's make it really, really easy to get started for students. So one of the projects we're trying, this is a pretty common feature in Carla, and this is one of the exercises students are doing. They use a YOLO, which is very popular computer vision application. It's called you only look at it once. I think it's you only look at it once or something like that. I forgot the details, the full abbreviation. So currently, I believe version 8 or 9 are probably version 8 is already out. When we were using this, probably using version 3 or 4. I forgot the exact version for this one, but it's already working pretty well. Without training, you can directly load the weights already trained with some existing data set. And you can automatically detect some of the common objects. And if you really want to focus on cars, you can ask a YOLO to, because all the different categories will be will more or less like an index. So you can filter out all the non-necessary categories, just focus on cars. The YOLO can easily do that. It's just Python programming interface to YOLO can link it to the Carla, can get all this done in a very nice way. Another project that my student got started when they were working on this Anki challenge project is to insert some auditory data into the 3D assets. Okay, that's how we start doing this auditory information, even though, you know, this is the primary topic, the main topic of today's presentation, but now you see the whole topic, how the things are coming to this stage. So when we try to explore the information and how you can get information from Carla, consider you are a programmer, and you want to train a model that can help you do the autopiloting. You are trying to extract all the information you can. In Carla, at least the Carla you can find, you can download on their website, doesn't support auditory information, even the latest one. So it provides a lot of ways to provide a visual information using the point cloud data. You can use Carla to dump the point cloud data for the environment. You can use that to download simulated radio data. You can download RGB information. You can download the depth camera data, and multiple visual information is coming from different perspectives. And you already have the segmented image because Carla knows exactly if it's a building here, or if it's a road there, or if it's a traffic light here. It has all the labels already in the model, so you don't need to do any level data for training object detection or segmentation. It's already there, which saves a lot of time and resources just to get the data ready in Carla. But it doesn't provide auditory information. So as a driver, everyone or most of you probably know that when you're driving, you are not only just looking, you're hearing, especially the sirens from emergency vehicles, which actually are very, very important information. Sometimes some cars are passing through you, and when the flash when you see the flash, you can easily see that. But sometimes if it's across a corner, or when you're just turning, or the vehicle is on the other side of the building, you cannot see it. The only way you can see something is coming, or something important is coming, is from the auditory information. And this is the reason why one of the students proposed it to me, said, "Hey, Dr. Tao, let's start doing this. I think it's useful." And I think it's a very good idea. So what she did, Alyssa, she put the auditory information as a part of the 3D assets. So the regular 3D assets we talk about in Unreal and Carla, those are just 3D models, meshes, with some texture information and with some rigs. If you create animations, all these are just coming as a 3D asset. That's the 3D asset you can download from online 3D SketchUp places or Unreal Marketplace. But usually they don't have auditory information. Usually, some of them they do. In Carla, this is what we are doing. We took a couple of the 3D assets from Carla and insert auditory information. And then when the 3D assets is loaded, the auditory information or the siren sound, etc., will be loaded as well. And that's how we use this in Carla. But now the thing is, Carla doesn't support audio signal processing. So what we did, we modified the Carla. Seriously, the student got into the code and modified the user interface to enable the autopilot system to be able to see the information about auditory information. I'll show you, the snapper in a second. So some modification will be needed in Carla to support the audio signals, and autopilot system needed to be implemented on the client side to be able to process the audio signal and make some decisions and then do something about it. So this is more or less like what we did like 3 years ago. This is about 3 years ago, and we started with one single thread programming and just to get things started, but it turns out the performance was pretty bad, and some of the code just crashed right away because we are trying to do both the signal processing but also the deep learning based classification of the signal, and also you need to run Carla at the same time, which is very computer intensive. Expensive. So we decided to switch from the deep learning model to the relatively simple classification model using traditional machine learning method. It's simply using this classification method algorithms instead of using deep neural network. We were managed to reduce the computational costs a lot, and then we start doing the multi-threading in Python so that you can have the 2 threads ongoing, another one is waiting until something happens, and then both threads can continue working on different things. So by doing that, we gradually reduce the cost and makes the system much, much smoother than the very first version we tried out before. So this is one example. I believe when I share the links to the link of the slides, this should be coming automatically. This is already posted on YouTube a while back.
Much of the research.
So I'll mute here. Alisa was given as a providing narrative to this video, so you can take a look. I'll quickly go through this so you can see what we have been doing. So we started by showing how we added all these audio signals into this environment. And this is called a blueprint in Unreal. If you're not an Unreal programmer, it's fine. It's just like a visual programming interface. A lot of students in our school have been trying to do all this. And we use a Pi Audio to capture the audio signal. And the audio signal, now you should be able to hear some siren coming, but currently I just mute myself, shouldn't be fine. And then if siren's coming, the car will stop and pull over. This is a small, the interesting animation that Alisa created just to show the demonstration, but you all see a real video showing how this works in the Carla. And then after the siren is getting away, the car will be getting back. I'm sorry for the, this is just a neural network with a very rough, 3D model here. But you'll see some better visualization. But this is a very, very first version for everything work in a very rough stage. If you look to the left here, there is a one block called the siren detection. Press A, capital S A to stop. If you look at it's around the middle, it's an emergency vehicle detected. This is the part we added to the interface, autopilot interface, which is some work for students just to figure out where to do that, and it gives you a very good control, so that you can directly see how to get the audio, the sound detection activated. Just push a button, and this could be part of the things we can help to push to the Carla repository later on. We're not doing that yet, but I think we are getting back to the Carla developers and see if they're interested in adding this to their package. So when the siren detection is on, it will capture the audio signal from both microphone and the internal channel, audio channel. So essentially, if you have this model running, if you play the siren on your cell phone, it will trigger the car to pull over, because it's capturing the information coming from both the microphone of your computer, also from the internal siren asset from this vehicle. These emergency vehicles, we do add those siren signals into, so they do emit audio signals when they are passing by. Another beauty about this work is that the student considers the Doppler effect. So when the car is coming, I'm not sure you're familiar with Doppler, when your car is coming, the pitch will be higher, and then the frequency will be higher. The Pi Audio packet can detect that, so it's something is coming towards you, and then you start putting lower. When it's going away, the frequency will getting lower, your car will getting back to it. But of course, not just frequency, but also the amplitude of the wave is getting lower, because in Carla, the audio signal that we are currently working on, it's automatically attenuated based on the distance where the signal is and where your current receiver is. So again, it's some work, but fortunately, a student made it work on Carla, and now it seems pretty natural, pretty, how can I say it?
Much of the research around self-driving cars focused.
Sorry, let me go back to the slides. So this is a second version. This is a current version. So I ask Annalisa, I say, hey, Annalisa, let's use the latest version of Carla. Back then, I believe we're using 0.091 or 2. Now there's the latest version with a lot of fancy town buildings as well as other features added. So we did the work recently. That's when I heard from MOUSSA say, hey, Jen, you know, this looks something interesting. Let's start exploring it. So I asked my students, say, hey, let's just take the asset. Let's use the latest version of Carla. Let's try to redeploy it. So this is what we currently have. I'm so sorry. It seems, let me go back to, okay, this video. So this is using
Powerful simulation environment for autonomous
okay, so I'll mute this again. But let me try to play.
and high resolution environments, providing a robust.
I'm sorry, Mose, can you hear that? Here's a narrative from Alyssa.
Yes, we can. Yes, we can hear. Yeah.
Okay, that's great. Let me replay this.
Carla is a powerful simulation environment for autonomous vehicles. Built on Unreal Engine, it features a wide range of vehicles and high-resolution environments, providing a robust platform for testing and development. Our team has enhanced Carla by implementing a system for detecting emergency vehicles through auditory perception. We trained our system using open source datasets to accurately detect the presence of a siren. When the system detects a siren, the autonomous vehicle will automatically pull over until the siren is no longer detected. The detection system works by analyzing input from the microphone, which can be triggered by external audio sources or an emergency vehicle within the Carla environment. Using Unreal Engine, we've integrated siren sounds with the emergency vehicles in the simulation. By applying the Doppler effect, we can realistically replicate the sound of an approaching siren.
So this is the current status. We are just picking up, but now with the students getting more and more familiar with all the system, and also with the current ongoing effort here, we are building with Digital Twins. There's a lot of new possibilities out there, and that's something we are exploring. And we are just starting actually. Thank you, MOUSSA, just getting me started again on this. I almost forgot about this project. And so this is a flow chart. We are currently working on a paper just to get everything published together with all the 3D assets as well as everything. Everything will be out openly available for everyone to try out. So this flow chart basically shows how things are working. Since I believe the time is almost 40, but I think I can go through this quickly. So we start by map creation. This could be done separately, starting from all the top left here. And then we added some sound files in Unreal and then merge that with the 3D assets of the cars. And then the cars, emergency vehicles will make noises when they're getting closer or getting inside of this thing that when you're in a Carla environment. Of course, when you have a very big map, when the vehicles are pretty further away, you won't be able to hear that. But getting closer to you, or it's inside your current view window, you will hear the sound from those audio signals. And then we run this, put this into this virtual environment, and we can do something about it. And then when you start running the simulator, you can set up your own car, or you can pick your car using the Python API, or you can directly try things out using this interface, Carla interface. And we can run Python script to create all the sceneries. We can do a lot of other things, modify the weather system, and change the number of cars and people walking on the street, etc. All this could be directly controllable. And the audio samplers from the simulator, either from the 3D asset of all the emergency vehicles, or from some signals outside picked up by the microphone, will be captured during the simulation environment, during the simulation procedure, and then try to make decisions. So how to react to it, it's completely up to the user. You can ask the user to pull over to the right, or you can ask the user to stop, you can ask the user just to do something about it. But that's completely up to the developer. That's on the client side. So we provided this framework that actually make it much simpler to utilize the auditory information as part of the perception system of your environment. And also we create a very simple maneuver practice for controlling the actors inside this environment based on the auditory information and perception information we got. So this is the overview of the project. And but again, I'll be happy to talk with you if you have any other questions. And most of the development was done by the students. I'm just more or less like supervising this and providing some suggestions and help them identify models and Python modules for them to utilize. And we are currently working on a paper, and we are making this public accessible, hopefully in 2 or 3 months. Okay, that's all of my talk. Thank you all so much.
Thank you so much, Dr. Tao. I really appreciate your presentation, and it was insightful. Thank you. I have a few questions. Let's see. There's one question from did you use pre-trained data, or you have trained the data which you are using, and how you trained it? Please.
Yeah, the data are mostly audio signals. Kind of interesting. When I still start looking for those files, they found most of the recording from Europe. So they started getting back to Cargo. Back then, it was not acquired by Google yet, or acquired, I forgot. But Cargo has a lot of online data sets. So they found some of those siren information, either emergency vehicles or, I think it's paramedic vehicle sirens, and also police sirens and fire trucks. So they can do the classification. So we are not identifying particular sirens in the Carla environment yet, but and you may imagine easily doable by not just telling it's a siren, but also telling you what kind of siren or what kind of vehicle it is. And it's more or less like a classification problem for audio signals. Nowadays, almost trivial. Back then, when students just started learning doing this, it took them some time to figure out how to do it. So the data set is mostly from online resources.
Okay, thank you so much. We have another question is here. Why don't you apply the latest versions of YOLO, such as the YOLO V8, which gives a high accuracy for detecting ambulances?
Yeah, that one was done in 2020, I believe. So we haven't really done much object detection currently for our project. We are just focusing on the 3D environment. But again, those object detection method and similar research has been published, by many groups, and there's a lot of ways to do that. So feel free to use it. Again, it doesn't limit to our project. Carla does support connection to multiple computer vision packages outside, so you can directly use those tools directly with Carla. So it's not limited to us, so anyone can use those. But we just use that as a demonstration as a student project back then in 2020.
Thank you. I have one more question. Is Carla available for people to, for students to download and to use, and how to get the software?
So again, if you can get back to MOUSSA, I can share directly with you. The main reason is that we are currently working on a paper just to get everything out. As you may imagine, there are some issues with the RP office. They want us to get things published before we release everything. So we are currently working on this. And if you really want to get it, you can contact MOUSSA, assuming, if it's through a collation. And we don't need to sign any MO here, but I'll be happy to share this, what we currently have with you before we release it.
Thank you, I appreciate it. You can share it with me, Dr. Tao. I can share it or ask for it.
But again, those are not the pre-compiled modules that you can download and use it. You have to compile it, and it's a lot of work. And we all, in this process, when we're preparing this release, we're preparing documentation as well. A pretty lengthy process. Sometimes just compilation will take you probably hours, just compiling things.
Well, when do you expect it to be available? Could you...
2 or 3 months. So we're targeting a conference paper, and the students are currently working on it. Just for this, we didn't add something extra, but we do plan to add some noise detections for car to check if your engine is working or not. That's something else we want to do. But again, that could be in our proposal.
Okay. One more question. How is Carla simulator different from when compared to Alexa? Are we just for auditory purposes building this project by installing Carla simulator? I'm not sure the question is not that clear, but
let me see if I have the question here. Do you have? I'm sorry. I saw the question.
Really, it's how is Carla simulator?
Yeah, I believe it's mostly about the classification, right? Unless I'm not sure. Do you mean another simulator?
Yeah, they're talking about Alexa. But I think maybe referring to Amazon or
Amazon Alexa. I do have Alexa home, but I thought this might be referring to another simulator. I haven't. So Alexa is a smart assistant. It's not doing simple classification. It's more than just simple classification. Our model is much simpler. It's more or less like a classifier when you use your phone to tell if the desk or chair. We're using the audio signals to do that, not the images, right? So it's a classifier. It's a much simpler application. There are some traditional machine learning methods you can use them to do the classification. You don't need to use neural network for that. The key here is to capture the frequency and the amplitude profile, and then you can build a model to tell the difference.
Thank you. Do you see, as an expert in transportation systems, how do you see the future of autopilot systems? Yeah, we keep hearing about it, and
it's there. It's just like something when everyone else is starting using it or be working nicely, but then it's just like all the rules you put in the traffic, the traffic control rules you put in there. If everyone follows, it works perfectly. It's just like when someone's not following, the whole thing will be going down quickly. It's the same for the autopilot system here. If all the cars can communicate to each other and you can get the system set up, it will be like in harmony. When you are in a stop sign, whenever stop sign in a traffic light, whenever the light turns from red to green, all the cars can move all at once because they know exactly when it will start. So that will dramatically make all the transportation much more efficient if we are going to that state. But again, it's always a transition step. Some people start using that, some people not. Some companies have more advanced technologies that don't want to share. So it will be, I don't see that coming very soon, mainly because the way how all our society is working. It's always a lengthy procedure for this kind of transition. Another big concern is about the liability. Are you going to sue the AI for that, or suing the company, or suing the data provider? There are many discussions, and also there are many decisions that AI is making might not be directly following our traditional way of thinking, and it's just kind of hard to legalize all this. And in some countries, in China, there have been some demonstration about this autopilot taxis. But again, the people have been complaining about some issues caused by those taxis. It's always like that. Just be prepared to on this ride of this autopiloting system, but also just be cautious, for all the damages this kind of system may causing. So.
Thank you. One more question. I have a question myself as far as how can such a simulator or such tools help us with resiliency of our transportation systems, as far as building more resilient from different perspectives? And security is one of them, but any way you think such tools can help us with that?
Yeah, again, this kind of system is very good for simulating those corner cases and different scenarios, which might not be easy to provide data for training your autopiloting system. And creating those scenarios, I'm most talking about the transportation system itself. You can use this to show how different design of of the highway can help you with certain traffic control, etc. People have been doing this agent-based models as well, but this will give you a different perspective by integrating the AI, machine learning, etc., into this whole environment. But as far as resilience is concerned, I think it's mostly about disasters control, management, emergency management, and also the cybersecurity kind of problems. Those are hard problems to resolve. I think these simulations, it's kind of like very similar to a recent proposal we're preparing for the medical system. And you need people from different background, different knowledge to come together with a solution. And the solution you're providing might be working well for you for certain scenarios, but it's kind of hard to generalize those. The way to do it is to have simulators like this to help you with correct different scenarios, so you can generalize your solution. It's very similar to do the data augmentation when you're doing machine learning or deep neural network training. You want your data to be to cover different cases, so then your solution, your model training will be more generalized with less bias towards certain situations. And that's one of the, I believe that's one of the major contributions this kind of simulator will be contributing to this future transportation systems, basically providing data sets which might not be easily accessible through the real world scenario, in the real world scenarios, and give you the extra information needed for training this kind of model, because there's no other way you can get your model trained without sufficient data to provide the information needed, at least for the current model we're developing. But in the future, if you combine the rule-based models and also the incoming data, things might be different.
Okay, thank you so much. I have one final question about such a tool. Like, do you usually, as faculty members, when try to use such tools in the classroom for educational purposes, sometimes we don't have like a training module, like training clips or training resources. Are you planning to provide any training resources for such a tool when it's released, or?
It's depending on which level, because it kind of like a machine learning model. You can either developing algorithms or you're using this machine learning models for your application. If you're just trying to use this for teaching, say, training your reinforcement learning autopiloting program, this could be readily available. You can directly download it and run it, and that's it. If you want to modify part of it and do something like how to to control the behavior of all the cars, etc., that's a different problem. You need to get into Carla, get into the system to figure out how to do it. But if we just use this environment as a generator to generate data for something else, it should be trivial to use. You don't need a training. But if you want to dig into system like what my students were doing, you need to get to the source code level, understand Carla, how the Carla is working, understand the environment system, how to use the Python APIs to change here and there. That's the different level. Carla does have a very decent documentation. That's why my student got started. I'm not expert on Carla myself. Students that just learn everything from those APIs to do all the fancy stuff. So we can provide something. Actually, it's part of the plan to provide some training materials based on this as well. But we cannot promise anything in the near future for this one. Yeah.
Okay. Okay. Thank you so much. We are really on time. Very on time. It's any final question from the participants or like the attendees? Okay. On behalf of Chicago State University Carnations Project and the CINSER team, we're very thankful, Dr. Tao, for your time, presentation, and resources you shared with us. Thank you so much. And
yeah, I'll share the slides with you. You can share with all the participants, and then just feel free to email me. I'll be happy to talk with you. I'm not teaching this semester. I'll be happy to answer all the research questions and get started.
Thank you. I will be posting this on our website also. We'll put the recording of this on the website.
Yes.
Thank you so much.
That's
and
great. Thank you so much.
Informative. Thank you.
Take care.
This concludes this presentation. Thank you.
Bye-bye.